All right, so let's look at some exponent laws, the basic ideas of how to do exponent stuff. So we'll start with the basics. So multiplying, dividing, doing an exponent, or doing a radical. Whenever we're multiplying exponents, first thing we have to understand is they need to be the same base here. So like they both need to be x. So x squared times x to the 4. What we do is we add the exponents together. Okay, so this would become, so this would become x to the 6. If we were doing dividing, it's going to be subtracting. So it would be like y to the 3 minus y to the 5, which would be y to the negative 2. We'll get to negatives in a minute because there's a special case with those. In this case, it's exponents. So we do multiply. So here was adding, here was subtracting, here's multiplying. So it's actually going to be a to the 3 times 4, which is a to the 12. Okay. And then the last one, you probably guessed, is dividing. This is where we actually take whatever this exponent is and we divide it by this exponent. If you can't see something on the radical, it means it's 2, like a square root. So in this case, it would be a to the 6 divided by 2. So it would be a to the 3. The way that I think of it is everything's kind of 1 degree lower than what it should be. So when we're doing multiplying, we actually add, which is like multiplying just like to a lesser degree. When we're dividing, we subtract. When we're doing exponents, we don't actually do exponent, we do multiply, which is like 1 step lower. And again, when we square root, it should make things smaller, so we divide to get a smaller number. That's the basic process of exponent laws. You need to have these basics down to be able to do harder questions. I also want to talk about these ones, these weird examples over here. So fractions. So this is where you get a question like x to the 3 halves. Okay? The way that it works is that the numerator, the top number, is the normal exponent. So that becomes like x cubed. The denominator of the fraction is actually part of a radical. So in this case, it would be square root. If we had a different one that was like, I don't know, y to the 5 over 3, that would become y to the 5, just like with that numerator, but then it would be cubed root because of that third. The other one we need to deal with is negatives. So whenever you have a negative value, like y to the negative 2, it actually just moves under the denominator and becomes squared. It keeps the same number, but then it just loses the negative when it shifts. So for example, if we had something like this, a squared b negative 3 over x negative 5, okay? The b negative 3 is going to move down, and the x negative 5 is going to move up. So the end result for that question, the a squared doesn't move because it's still squared, would be like this. Okay? The last example we need to know is just like anything to the power of 0 is just going to be 1. It doesn't matter what it is. If it's a 3, if it's a 3 to the 0, if it's a variable, it always equals to 1. That's even true if it's something really complicated. The other thing we should mention is if there's something like this, x squared y 1/2 all to the power of negative 3 over 2. Okay? The way this is going to work, kind of like distributive property, this exponent is going to apply to everything inside the bracket. So if we had the question like that, I'm going to do a squared times negative 3 over 2. So it'd be like x squared times negative 3 over 2. It's going to be negative 6 over 2. And then y is going to be negative 3 over 4. Yeah. And then again, you just need to simplify. So these would change into x to the negative 3 and y, that doesn't simplify, negative 3 over 4. I'm going to deal with the negatives, so I'm going to move them to the denominator. So it becomes like this. Okay. And if you wanted, depending on the question, you could change that into a radical, and it would become something like this. The only other thing I want to mention is sorry, no, I think that's okay. That covers most of the basics about what we want to do. I guess just the other thing to be careful of is if you have something like this, you just need to realize that like these can't go together. You can't add exponents. Even if it's something, the only thing we can do is if it's like this, it means we have 2x squared. try not to get mixed up with those. This is like collecting like terms, and it's a lot easier. When we start to do multiplying stuff, that's where things get weirder, and we have to add them together. So those are the basic exponent laws, and that's it.